Alright, hi everybody. Today we're going to work on lesson 8.2, multiplying and factoring. So our objective for the day is I can multiply a monomial by a polynomial, and I can factor a monomial from a polynomial. So the first problem we're going to approach today is multiplying a monomial and a trinomial. So this is the distributive property that we have seen all year long. We need to make sure we take special notice of what our signs are, so pay attention to those negative signs. And we need to remember our exponent rules from the last chapter. So we're going to start off. 5n times 3n to the third. We're going to start by multiplying the coefficients. 5 times 3 is 15. N to the third times n is n to the fourth. Next up, we've got 5n times negative n squared. So we have a negative 5n to the third power. We add our exponents when we have the same base. Last term, 5n times 8. 5 times 8 is 40, and we still have the n there. Letter B, Ms. Zirzo is pointing out that we are distributing a negative 3x squared, and she's pointing out that we have a negative 2x and a positive 3 there as well, so let's remember those signs. So negative 3 times a positive 4 will give us negative 12. X squared times x squared is x to the fourth. Negative 3x squared times negative 2x, negative times negative is positive 6. X to the third power. And lastly, a negative 3 times a positive 3 will give us a negative 9x squared. Feel free to pause these videos at any point, work the problems on your own, and then check your answers with us as we go. So we're distributing negative 2x to each of our terms. So we have a negative 2x times a y squared. Can those be combined?
Sure. We're multiplying.
I don't think so, because those don't look like they have the same base to me. One has an x and one has a y. So we can rewrite that as just negative 2 xy squared.
Combined.
Alright, negative 2x times a negative 4y. Negative times negative is a positive. We got positive 8xy. And lastly, negative 2x times a positive 3 gives us negative 6x. Now make sure that you guys aren't trying to add the exponents of the x and y, because those are two different variables, so they are just being multiplied. Our last problem in this section, we have x squared being distributed. X squared times 3x to the third, we have 3x to the fifth power. We have the negative 2 coefficient in front, and it's going to be x to the fourth. And lastly, we're going to have a plus 8x squared.
Beautiful.
Now, the next page in the notes, we're going to combine problems 2 and 3 in the textbook. We are going to find the greatest common factor, and we are going to factor it out of the expression at the same time. So to do this, we're going to list each of the terms in our expression. We have 3x to the fourth, we have a negative 9x squared, and we have a negative 12x. And we're going to break these each down into all of their factors. So we have 3 times x times x times x times x, 3 times 3 times x times x, and we have a 12, which breaks down into 4 and 3, and an x. And don't forget that we're going to have a negative in our second and third terms because they are negative. Alright, so we're looking for what is our greatest common factor. So we're going to circle factors that all three terms have in common. We have a 3, and each of our terms has an x. So our greatest common factor is 3x. So now we're going to write the rest of the expression. On the first line, we see we have 3 x's remaining, so it's going to be x to the 3rd power. Our second line, we have negative 3 times x, so we are subtracting 3x. And for our last term, we have just a negative 4, so we just write negative 4. So we have found the greatest common factor, which was 3x, and we have taken that out of the expression. So this is the reverse of the distributive property. We are taking out something that is being distributed in. And you can always check your answer to verify that you have the right greatest common factor by distributing. For letter B, we're going to take the same approach. We're going to list each of our terms and make a little table. So we have a 6x to the 3rd power, we have 12x squared, and we have an 18x. So we break these factors up. We have 2 times 3, and there's going to be 3 x's. We have a 2 times 2 times 3 with 2 x's. And a 2 times 3 times 3 with 1x. So let's identify what are our common factors that we are seeing in all 3. We have a 2 in all 3. We have a 3. And we have an x. So our greatest common factor is going to be 2 times 3 times x, which is 6x. And if we look at our top line, what remains is an x squared. Our second line has a plus 2x. And our third line has a plus 3.
Kind of fun. I'm liking this.
Yay! All right, we're going to follow the same pattern. We're going to list our terms. 9x to the 6th power. We've got a 15x to the 4th power and a 12x squared. All right, so let's identify what are our common factors. We have a 3 in each term, and I see 2 x's in each term that we can highlight. So our greatest common factor for letter C is a 3x squared, and what remains is 3 times x to the 4th power, a plus 5 times x squared, and a plus 4. So at this point you might be thinking, I really don't want to write all these numbers out for everything. So let's look at letter D without listing our factors. If we look at our lowest x term, we have x squared. So all 3 terms have an x squared in them. So we can divide all of them by x squared. I also notice that we have a negative 6, a negative 18, and a negative 12. They are all multiples of 6. So we can factor out a negative 6 from all 3 terms. So now when we divide negative 6x to the 4th by negative 6x squared, we have x squared. Do the same thing, negative 18, remember that negative sign, divided by negative 6x squared, we're going to have plus x, plus 3x, and we do the same here, we're going to have a plus 2. So our last problem for the day is going to be applying these factoring rules to some real-world kind of scenarios. So our first example is write an expression in factored form that describes the shaded area in the following square using the given dimensions. And we're told that it is a square, so each side is going to be side length 3r. And we have a circle in there with a radius of r. And if we remember, the area of a circle is pi r squared. So what common factors do we see there? Well, I see that there's an r squared in both terms, so we can pull that out. And what remains? Well, that 2 is going to have to be distributed to the 3. So 3 to the second power is 9, and we take away pi. So letter B, we have a circular mirror that is going to be surrounded by a square metal frame. The radius of the mirror is 5x, and the frame length is 15x. Now, Mrs. Zirzo immediately drew a picture on this one, because anytime we have a word problem which is describing a scenario, we want to draw that picture. It'll help us visualize it. So we want to know what is the area of the frame around the mirror. So we have 15x squared. We were told it was a square frame. And we are going to subtract pi times the radius squared. And the radius, we said, was 5x. So as we get set to factor this, we can distribute our squareds to each of the terms inside the parentheses. So we'll have 225x squared minus pi times 25x squared. And I see that we have an x squared that we can factor out, as well as a 25. So 225 divided by 25 will give us 9 minus pi. Okay. Our last example for the day, you're going to be painting an accent wall shown below that has a doorway. And we want to know what is the area that we're going to have to be painting. And Ms. Zirzo made it a nice door. So we have the area of our wall, which is 15W times 6W, and we are taking away from that the area of the doorway, which is 3W times W. So when we do our multiplication, 15 times 6 is going to give us 90W squared, and we are subtracting 3W squared from that. Again, we see our variable terms. We've got a W squared, and we can factor out a 3 from 90. So 90 divided by 3 is 30. And we are subtracting 1. Can we simplify that further?
I think we can. Not yet. Can't have your homework yet.
And we will see you all in class tomorrow.